Social environments interact with elevated dopamine levels to enhance the stimulating effects of ethanol. The behavioral effects of alcohol consumption can vary depending on whether it occurs in a social or solitary context. Social drinking is typically linked to positive outcomes, while solitary drinking is often associated with negative ones. However, the neurobiological mechanisms underlying how the social environment during alcohol consumption influences behavioral responses are not well understood. This study explored whether different social settings affect behavioral responses to ethanol, and examined the role of the dopamine system in this process using the fruit fly Drosophila melanogaster. Wild-type Canton-S flies exhibited increased locomotor activity when exposed to ethanol in a group setting compared to when they were alone. With no observed difference between males and females, dopamine signaling plays a key role in the locomotor-stimulating effects of ethanol. When exposed to ethanol in isolation, dopamine transport mutant flies fumin or FMN, which have elevated dopamine levels, exhibited a similar locomotor response as wild-type Canton-S flies. However, when these FMN flies were exposed to ethanol in a social setting, their locomotor response was significantly enhanced compared to the CS flies, suggesting a synergistic interaction between dopamine signaling and the social environment. To pinpoint the specific dopamine signaling pathway involved in this social effect, researchers examined flies with defects in individual dopamine receptors. They discovered that the D1 receptor, DDA1.1R1, is the primary receptor responsible for mediating the social effect. Overall, this study highlights the significant impact of social context on the neural and behavioral responses to ethanol.